Do you want to know what the basic parts of an ellipse are? And how do you actually form an ellipse? What does the focus have to do with any of it? Well, that's what this video is about. Let's find out. If you'll pardon the pun, we're going to focus on 2 points for a minute. We're going to focus on this point, F1, and we're going to focus on this point, F2. Why? Because F1 is a point that we call the focus, and F2 is a point that we're going to call a focus as well. There's a certain pattern with this focus, and any point on this ellipse. And basically what happens is, let's first of all take a distance. If we measured how far it is from the point P to the point F1, you'll notice that from P to F1 is 8.2. And from P to F2 is 7.8. If we added up those two distances, we're going to end up with 16. What happens if we move to another point? This time, from P to F1 is 9.4, and from P to F2 is 6.6. If we added those two values, we still get 16. So it turns out, pay attention to what's happening here, pay attention to this sum, no matter what happens to where we are. So these two values will change, PF1 and PF2, those distances will change. In other words, this one's a little bit longer, this one's a little bit shorter, but what happens is when we add up those two distances, it's still 16. For a different ellipse, it'll be a different number, it won't necessarily be 16, but basically for any ellipse, the distance between a point and a focus plus the distance between the same point and another focus, that sum, those two distances added up will always equal a specific number, and that number is specific to the ellipse that we have. Here's an example of an equation that when we graph it is going to give an ellipse, but what exactly does that look like? Here's what it looks like, and we're going to put some specific names to some things. Well, we know the center is right in the middle. And we'll notice that there's a very long part that goes from the top here to the bottom. The long part at one end of it, that point we're going to call it the vertex. At the other end of it, we're also going to call it a vertex. So basically the line that goes from the vertex through the center to the vertex, that's going to be the longest line that we can make on this ellipse. We're going to call that the major axis. So the line that goes from the vertex straight through is what we're going to call the major axis. So the major axis is going to have some important points on there because it's major. It's going to have the two vertices, so this vertex and this vertex. It's going to have the center, but it's also going to have those 2 points that we talked about. It's going to have the two foci, so a focus here and a focus here. If we looked at the shorter line that we can make, that would go from one side to the other and straight through the center, the endpoint here is called a co-vertex because it's not as important as a vertex. It doesn't make that major line. So this point right here is called a co-vertex. This one right here is also called a co-vertex. So these are the two co-vertices. So that's some of the basic vocabulary that we have as it comes to ellipses. What would happen if we change the equation a little bit? Instead of having the positive 25 underneath the y part of it, what if we put the larger value, the larger denominator, that positive 25, underneath the x part of our equation? How would that change the graph? This is what our graph would look like now. If you notice that the long part, instead of going up and down, it's now going left to right. So in other words, instead of going vertically, that long part, the major axis, is now going horizontally. So that's basically what the change indicates. The larger value, wherever it is, so if the larger value is underneath the x, that means that the larger side, the longer side, is going to go the same way the x does, left to right. If the larger value is underneath the y, that means that just like how the y goes up and down, the longer side will go up and down also. So the key thing on determining how an ellipse goes, whether it's horizontal like this one is, or vertical like the first one is where the where the larger denominator is. If the larger denominator is under the x, then it's going to be long in the x direction. If the larger denominator is under the y, then it's going to be long in the y direction. But basically, everything else that we know is going to be the same about the two vertices being on the long side and the two co-vertices being on the short side. The two focus points, the two foci, are going to be on the long side, and they're going to be right next to the center. All that is still going to remain the same. So let's do a quick summary of what we learned so far. First of all, these ellipse equations are going to be in this format where they're going to always equal 1. The second thing is that depending on where the larger number is, that's going to tell you how the ellipse is formed. If the larger number, this 25 here, that larger denominator is under the y, that means it's going to be long in the y direction. It's going to be long up and down. If the larger denominator is under the x, then that means that it's going to be longer or larger in the x direction. So it's going to be longer or larger horizontally. So let's summarize everything. We know that an ellipse is either vertical or horizontal, and depending on where the larger denominator is, that's what's going to tell you if it's vertical or horizontal. If the larger denominator is underneath the y, then that's going to give us something that's vertical. If the larger denominator is underneath the x, then that's going to give us something that is horizontal. So it's basically going to go the same way that we know everything goes. So x is horizontal because the x-axis goes left to right. Y is vertical because the y-axis goes up and down. Thanks for watching.